In this video, we're going to talk about how to calculate specific heat. The formula for specific heat is going to be Q equals mc delta T. Here, Q equals energy, and we do energy in joules. Here, M equals mass, and in this case, mass can be in grams or kilograms, all right? It can be in either one. It depends on what our constant looks like. C is that specific heat constant, or you may hear it as like specific heat capacity, something along those lines. That can have different units, so we'll get into that as we come up with it. And here, this is the change in temperature. It needs to be in Kelvin or degrees Celsius. So it can be in either one of those. For our first problem, we have a 13.25 gram mass piece of iron absorbs 975.6 joules of energy, of heat energy, and its temperature changed from 15 degrees C to 137 degrees Celsius. Calculate the specific heat capacity of iron. One thing that I forgot to mention on the previous slide, I'll just pick it up real quick right here. I did say that this is temperature. This triangle, it's what we call delta. Okay, that's a Greek symbol, delta. This always means change in. So change in. So when you have something like delta T, this stands for change in temperature. All right, change in temperature. And the way you do the change in temperature is always going to be the final temperature minus the initial temperature. And so we'll definitely get into that while we're solving these problems. So if we line up the information that we're given, which is always a good plan, we have a mass of 13.25 grams. We're given energy. So in this case, energy is Q, 975.6 joules. And we're given two temperature changes. So we're given an initial temperature. I'm going to abbreviate that as TI. So initial temperature of 15 degrees C and a final temperature of 137 degrees C. It's asking us to calculate C, which is the specific heat capacity. In terms of units, joules is energy, that's correct. I told you temperature could be in Celsius or Kelvin. These are both in Celsius, so that's fine. And then I told you mass could be in grams or kilograms. So right here, grams is also fine. So we don't need to do any unit conversions. The only thing that we need to do is first we need to solve for our delta T, because we have that variable kind of missing right here, right? So we don't have this TI or TF up here in this formula. We have the delta T. And so remember, delta T is the final temperature minus the initial temperature. So if we plug in our values, that's 137 minus 15. That's going to give us a change in temperature of 122 degrees Celsius. So now we don't need this information anymore. We've used that information. But now you can see that we have all the variables that's needed to solve this equation right here. The last thing that we need to do is put C, or the specific heat capacity, on a side by itself. So the way we're going to do that is we're going to divide out M and T from both sides. So divided M delta T, M delta T. So that's going to cancel out on these sides. And that's going to leave us with C equals Q over M delta T. Now, if you're not super good with rearranging, if you just like to write this down as a formula and have it on your paper, that's also fine too. So here we're just plugging in variables. Q is 975.6 joules divided by the mass, which is 13.25 grams, times the change in temperature, which is 122 degrees Celsius. Put this in our calculator, keeping order of operations in mind. And this should give us a specific heat capacity, or C value, of 0.6. In terms of units, none of these cancel out, so we need to carry the units all the way through. So this is going to be joules times, or joules divided by grams times degrees Celsius. So that's going to be our answer in this case. How many joules of heat are needed to raise the temperature of 12 grams of aluminum from 18 degrees Celsius to 53 degrees Celsius? If the specific heat of aluminum, or I guess, yeah, is 0.9 joules grams times degrees Celsius. So here we're going to line up the information we're given. We have mass equals 12 grams. We have initial temperature, and of course it says it right there, initial temperature of 18 degrees Celsius, a final temperature of 53 degrees Celsius, and then a specific heat, a C value of 0.90 grams or joules divided by grams times degrees Celsius. Again, we're going to make sure that we're solving for the right thing, and it specifically asks how many joules of heat, so that's Q. So right now we have all of our variables for this except the delta T again. We need to have that delta T in that form. So delta T equals TF minus TI, which is going to be 53 minus 18, and that's going to give us a value of 35 degrees Celsius. So again, we no longer need these two pieces of information. We're going to use this delta T to solve our problem. Now, in terms of whether or not we have the correct units, we really need to look to this units on our specific heat capacity. It lists the units as joules, grams, and degrees Celsius. So we have degrees Celsius here, that's fine, and we also have grams there, that's fine. If for some reason we had this as 12 kilograms, we would need to change that to grams to match what's in this specific heat capacity constant. But for now, we're completely fine. And so we're solving for Q. Q's already on a side by itself. So we just need to plug in values here. So mass of 12 grams, make sure to include your units in these guys. 0.9 joules divided by grams times degrees Celsius. And lastly, our change in temperature, which is 35 degrees Celsius. Here we're just multiplying straight through. 12 times 0.9 times 35 gives us a value of 378. Now the question needs to be, what are the units of this? And of course, if you look in our problem right here, it very specifically says joules of heat. So you can just honestly probably say, oh, well, I know energy is joules and we can put joules down. But if we look at the cancellation of our units, grams and grams cancel, Celsius and Celsius cancel, and that leaves you in joules. Here, if for some reason you had kilograms in here, this would be a way to catch yourself and say, hey, well, kilograms doesn't cancel with grams, so I need to do my unit conversions. However, you know, as long as you're keeping up with your units, you should be fine. Here we have 120 grams of water, so I'm going to actually write down the variables as we go this time. You may enjoy that more. So we have 120 grams of water. It's heated from 7 degrees to 42 degrees. So here it's not clearly labeled initial and temperature, but if we started, we're at from. So from is initial, 7 degrees Celsius, and we're going to 42 degrees Celsius. That's going to be our final temperature. So, and then it also says if the specific heat, our specific heat is the lowercase c, 4.18 joules divided by grams degrees Celsius. Calculate the amount of heat energy needed to rise in temperature. This is our Q value. Again, first thing you need to do is do the delta T expression. So that's 42 final minus initial. That should give you a value of 35 degrees Celsius. So we no longer need these two numbers. We're not going to use them anymore. We have our delta T. Next thing is that we need to check units. We have Celsius here and Celsius here, so that's fine. Grams here and grams here, that's fine. Now we just need to plug it into our equation. So Q equals the mass of 120 grams times 4.18 joules divided by grams times degrees Celsius times 35 degrees Celsius. Again, our units are going to cancel here, and it's going to leave us in a value of joules. Now we just need to multiply everything. 120 times 4.18 times 35, and it should give you a value, and this one's actually quite large, and that's okay. It's 17,556 joules. For our last problem, we have 49 grams of water. Make that 49. We have 49 grams of water. It's heated from 5 degrees to 72. So here I'm just going to calculate our change in temperature. This is going to be our initial, and this is going to be our final. So 72 minus 5 equals 67 degrees Celsius. And then the specific heat of water is 4.18 joules grams times joules divided by grams times degrees Celsius, and here we're solving for Q. Again, all of our units match, so we don't have to do any unit conversion here. So Q equals, of course, we're calculate the amount of heat energy needed. That gets our question mark. 49 grams times 4.18 joules divided by grams times degrees Celsius multiplied by 67 degrees Celsius. This is going to also give us a rather large value, which I'm just going to round to the nearest whole number. So it'd be 13,723 joules, because again, all of our units cancel, leaving us with joules. So as always, if you have any questions, please feel free to message me and I'll be more than happy to help you.